Scrum is an agile software development method that was conceived by Jeff Sutherland and his development team in the early 1990s. In the recent years, further development on the Scrum methods has been performed by Schauber and Bedley. Scrum principles are consistent with the Agile Manifesto. Scrum principles are consistent with the Agile Manifesto and are used to guide development activities within a process that incorporates the following framework activities: requirements, analysis, design, evaluation, and delivery. Scrum incorporates a set of process patterns that emphasize project priorities, compartmentalized work units, communication, frequent customer feedback, backlog, a prioritized list of project requirements or features that provide business value for the customer. Sprints consists of work units that are required to achieve a requirement defined in the backlog that must fit into the predefined time box. Demos deliver the software requirement. Demos deliver the software increment to the customer so that functionality that has been implemented can be demonstrated and evaluated by the customer. Scrum meetings. Scrum meetings are short, typically 15 minutes meetings held daily by the Scrum team. These three key questions are asked and answered by all team members. What did you do since the last meeting? What obstacles are you encountering? What do you plan to accomplish by the next team meeting? A team leader called a Scrum Master leads the meeting and assesses the responses from each person. The Scrum meeting helps the team to uncover potential problems as early as possible. Also, these meetings lead to knowledge socialization and thereby promote a self-organizing team structure. The dynamic systems development method. The dynamic systems development method is an agile software development approach that provides a framework for building and maintaining systems which meet tight time and constraints through the use of incremental prototyping in a controlled project environment. The consortium has defined an agile process model called the DSDM cycle that defines three different iterative cycles, preceded by two additional life cycle activities. Feasibility study establishes the basic business requirements and constraint. Business study establishes the functional and information requirements. Functional model iteration produces a set of incremental prototypes that demonstrate functionality for the customer. Design and build iteration revisits prototypes built during functional model iteration to ensure that each has been engineered in a manner that will enable it to provide operational business value for end users. Implementation. It should be noted that the increment may not be 100% complete. Changes may be requested as the increment is put into place. In the either case, DSDM development work continues by returning to the functional model iteration activity. DSDM can be combined with extreme programming to provide a combination approach that defines a solid process model, the DSDM life cycle, with the nut and bolt practices, extreme programming that are required to build a software increments. Agile Unified Process. Agile Unified Process adopts a serial in the large, iterative in the small philosophy for building computer based systems. By adopting the classical unified process phased activities, inception, elaboration, construction, transition, AUP, AUP, Agile Unified Process Iteration, addresses the following activities. What are those activities? First, I will brief them and then I will explain one by one. First is modeling, implementation, testing, deployment. Then we have configuration and project management, environment management. Yeah, so now I will discuss each of them. Now, modeling. Modeling is UML representations of the business and problem domains are created. Business and problem domains are created. Implementation, models are translated into source code. Testing, like XP, team designs and executes a series of tests to uncover errors and ensure that the source code meets its requirements. Deployment focuses on delivery of the software increment and the acquisition of the feedback from the users, from the end users. Then we have configuration and project management. In the context of Agile Unified Process, configuration management addresses change management, risk management, control of any persistent work. Project management tracks and controls the progress of the team and coordinates team activities. Environment management. Environment management coordinates a process infrastructure that includes standard tools and other support technology available to the team. Requirements engineering. Requirements engineering establishing the groundwork, eliciting requirements, developing use cases, building the analysis model, negotiating requirements, requirement monitoring, validating requirements. Requirements engineering. The first of them is requirement engineering. The broad spectrum of tasks and techniques that lead to understanding of requirements is called requirements engineering. From a software process perspective, requirements engineering is a major software action that begins during the communication activity and continues into the modeling activity. Requirements engineering builds a bridge to the design and the construction. Requirements engineering provides the appropriate mechanism for understanding what customer wants, analyzing need, assessing feasibility, negotiating a reasonable solution, specifying the solution unambiguously, validating the specification and managing the requirements. What are the tasks involved in requirements engineering? Tasks involved in requirements engineering is inception, elicitation, elaboration, negotiation, specification, validation, and then we have requirements management. Now, in detail, we will be discussing each of these elements. So inception is nothing but beginning. Most projects begin when a business need is identified or a potential new market or service is discovered. So business need is identified. Stakeholders from business community, business managers, marketing people, product managers defines a business case for the idea, try to identify the breadth and depth of the market, do a rough feasibility analysis, identify a working description of the project's scope. At a project inception, a basic understanding of the problem, people who want a solution, the nature of solution, effectiveness of preliminary communication, collaboration between stakeholders and the software team happens at project inception. Then comes project elicitation. In eliciation is nothing but extraction. Extraction. Eliciating requirements is difficult because of problems of scope, problems of understanding, problems of volatility. In problems of scope, identify the boundaries of the system. What is the scope of the project? Problems of understanding, domain, computing environment, problems of volatility, requirements may change over time. Elicitation may be accomplished through two activities: collective requirements gathering, collaborative requirements gathering, quality function deployment. Elaboration. In elaboration, there is explanation. The information obtained from the customer during inception and elicitation is expanded and refined during elaboration. This task focuses on developing a refined requirements model that identifies various aspects of software function, behavior, and information. Elaboration is a good thing, but you have to know when to stop. The key is to design the problem in a way that establishes a firm base for design. If you work beyond that point, you are doing design. Negotiation or cooperation. Customers, users, other stakeholders ask to rank requirements and then discuss conflicts in priority. Using an iterative approach, prioritizes requirements, assesses their cost and risk, addresses internal conflicts. Requirements are eliminated, combined, modified so that each party achieves some measure of satisfaction. There should be no winner, no loser in an effective negotiation. Both sides win because a deal that both can live with is solidified. Specifications. Specification can be a written document, set of graphical models, a formal mathematical model, a collection of usage scenarios, or a prototype, or any combination of these. For a large systems, a written document combining natural language descriptions, graphical models may be the best approach. However, usage scenarios may be all that are required for small products. So for small products, we will be using usage scenarios. That is what all required for small products. Then we have got validation. The work products produced as a consequence of requirements engineering are assessed for quality during validation step. Requirements validation examines specification to ensure that all software requirements have been stated unambiguously, that inconsistencies, so the software requirements have been stated unambiguously. Inconsistencies, omissions, errors have been detected and corrected, and that the work products conform to the standards established for the process, the project, and the product. Requirements management. Requirement management is a set of activities which will help project team identify, control, track requirements and change requirements at any time as the project proceeds. Many of these activities are identical to the software configuration management, that is SCM, software configuration management. So most of the activities are very identical or very similar to the software configuration management. Groundwork establishment for requirement analysis. Groundwork establishment for requirement analysis. What it consists of? It consists of identifying stakeholders. Who are the stakeholders for this project? Anyone who benefits in a direct or an indirect way from the system or the project or the software which is being developed. He could be a project manager, team members, team leads, project resource manager, senior managers, executives, or sponsors. Recognizing viewpoints. Put three stakeholders in a room and ask them what kind of system they want. If you are likely to get four or more different opinions. Marketing group is interested in functions and features that will excite the potential market, making the new system easy to sell. Business managers, they are interested in feature set that can build within budget and will be ready to meet defined market windows. End users may want features that are familiar to them and that are easy to learn and use. Software engineers may be concerned with functions that are invisible to non-technical stakeholders. Working towards collaboration, the job of requirements engineer is to identify areas of commonality, requirements on which all stakeholders agree, and areas of conflict or inconsistency, that is requirements that are desired by one stakeholder but conflict with the needs of another stakeholder. A strong project champion, a business manager, or a senior technologist may make the final decision about which requirements make the cut. Asking the first questions. Who is behind the request for this work? Who will use the solution? What will be the economic benefit of a successful solution? Is there another source for the solution that you need? How would you characterize good output that would be generated by a successful solution? What problems will this solution address? Can you show me or describe the business environment in which the solution will be used? Will specific performance issues or constraints affect the way the solution is approached? Now we go to the eliciting requirements. Eliciting requirements, also called as requirements gathering, combines elements of problem solving, elaboration, negotiation, specification. Collaborative requirements gathering Meetings are conducted and attended by both software engineers and other stakeholders. Rules for preparation, participation are established. Agenda is suggested that is formal enough to cover all important points but informal enough to encourage free flow of ideas. A facilitator can be a customer, developer, an outsider, controls the meeting. Definition mechanism can be worksheets, flip charts, wall stickers, electronic bulletin board, chat room, or virtual forum is used. Quality function deployment. Quality function deployment QFD is a quality management technique that translates the need of the customer into technical requirements for software. Normal requirements, expected requirements, exciting requirements. These are three types of requirements. Usage scenarios. Developers and users can create a set of scenarios that identify a thread of usage for the system to be constructed. The scenarios, often called use cases, provide a description of how the system will be used. Elicitation work products a consequence of requirements elicitation, a statement of need and feasibility, a bounded statement of scope for the system or product, a list of stakeholders who participate in requirements elicitation, a description of the system's technical environment, a list of requirements and the domain constraints, a set of usage scenarios that provide insight, any prototypes developed to better define requirements. Building use cases. Use cases are defined from an actor's point of view. An actor is a role that people, users, or devices play as they interact. Use cases are defined from actor's point of view. An actor is the role that people or users or devices play as they interact with the software. It is important to note that an actor and an end user are not necessarily the same thing. A typical user may play a number of different roles when using a system, whereas an actor represents a class of external entities, often but not always people that play just one role in the context of the use case. Once actors have been identified, use cases can be developed. Jacobson suggests a number of questions should be answered by use case. Who is the primary actor? Who is the primary actor? Who is the primary actor? Secondary actor? Actor's goal? What are actor's goals? What preconditions should exist before the story begins? What main tasks or functions performed by the actor? What exceptions might be considered as the story is described? What variations the actor's interactions are possible? What system information will the actor acquire, produce, or change? Will the actor have to inform system about changes, external environment? What information does the actor desire from the system? Does the actor wish to be informed about unexpected changes? UML, use case diagram for safe home security function. So this is a use case diagram. So you have got stakeholders or the homeowner, system administrator, arms, or it is arm system, access a system via internet, response to alarm event, encounters an error condition. Then you have got reconfigure sensors and related features. Then here you have got sensors. Sample use case diagram. This is a sample use case diagram. This is also a use case diagram. You have got a customer, technician, creating an account, login and log out, edit profile, home service reservation, view schedule, view history, view home service status. This is the admin. Building the analysis model.